Okay guys, welcome back to my channel. Now today, this is for the WAEC students taking the WAEC 2026 Physics Objective and Essay examinations tomorrow. If you will be entering the hall for the exams tomorrow, make sure you don't skip this video and make sure you send this video to all your friends that should be writing the exams as well. Let's get down to business. Now these questions today are questions you should be expecting somewhat in the examination. Okay, so try as much as possible to understand these questions and their solutions and apply them in your exam tomorrow. I wish you all success and the best. Question number 1 says, which of the following is a fundamental quantity? As the options are on the screen, option A, we have torque, B, we have reactance, C, heat capacity, and D, electric current. Now, quickly, before I give you the answer, what are fundamental quantities? They are quantities that exist alone, also called independent quantities. And we have about 7 of them. I'll give you an acronym for them. We have M, E, double T, A, and double L. This M stands for mass, and then the E stands for your electric current. Okay, the T stands for time, the other T is temperature, the A is amount of substance, okay, the L is length, and the last L is luminous intensity. So these are the 7 fundamental quantities we have in the entire physics. Now from the options given to us, which one is fundamental? The answer there should be option D, which is what? Electric current, option D. Question number 2. A boy cycles continuously through a distance of 1.0 kilometers in 5 minutes. Calculate his average speed. Now we are asked to calculate the average speed of this boy in 5 minutes. Now quickly recall that your average speed is basically your total distance traveled, okay, over the total time taken. Xt is your total distance and then T is your total time. Now the distance was given in kilometers while the time in minutes. We're going to convert those 2 parameters to SI units. So 1 kilometer also means 1 times 1000 meters, okay, and then the time was 5 minutes. That should be 5 times 60. So we're going to work with this, okay. 0 take out 0, 5 here, 1, 5 here should be around 20, and we have 20 divided by 6, and I think 10 divided by 3, and that should be 3.3 meters per second. Okay, question number 3 says, a student found out from a simple pendulum experiment that 20 oscillations were completed in 38 seconds. I think we are asked to find the period. Okay, now recall that a period in simple pendulum is a time taken to cover a number of oscillations. So the time given in the question here was 38 seconds, and then we have 20 oscillations. Now quickly, can 2 go into 38? That should be around 19. So 19 divided by 10, that should be 1.9. Okay, so the period is 1.9 seconds. Number 4 says a body of mass 7.5 kg is pulled along a plane which is inclined at 30 degrees to the horizontal. If the efficiency of the plane is 75%, what is the minimum force required to pull the body up the plane? Now quickly, this is under simple machines, okay, and the efficiency we call efficiency for a machine is mechanical advantage over velocity ratio times 100 over 1, okay, where the MA represents load over effort and VRO means distance moved by effort over distance moved by load. Now from the question, let's see, since it's an inclined plane, the velocity ratio for inclined planes is actually 1 over sine theta. So you can quickly get that value. The angle was 30 degrees. This should be around 2, okay? So VR is 2. Now from the question given, the efficiency was 75. Let's put our values. 75 equals to, now remember, MA is load over effort. Now the object we are moving is 7.5 kg as a mass. So the load should become 7.5 times 10, okay, over the effort we are looking for, okay, and this all divided by our VRH 2, then times 100 over 1. So let's work with this guy here quickly. 7.5 times 10 gives you 75. So we have 75 equals to 75 over 2e times 100. Quickly, we can disappear some numbers here. This takes out this, okay, and then 2e comes here. 2e equals 100, and then 2 into 100. Our answer should be 50 newtons as the answer. Number 5 says the angular speed of an object describes a circle of radius 4 meters with linear speed of 10 meters per second. Oh, we are asked to find the angular speed. Now for circular motion, recall that V equals to omega r. Omega is the angular guy, so omega becomes V over r. Okay, V was given in the question as 10 and r was 4. So this should be 2.5 rads per second. Number 6, at what angle to the horizontal must the nozzle of a machine gun be kept when firing to obtain maximum horizontal range of bullet? Now this from projectile motion, and for your range to be maximum, don't forget that the angle of projection to be horizontal must be equal to 45 degrees. So that should be the answer. Number 7, which of the following reduce the frequency of oscillation of a pendulum? Now remember, for a simple pendulum, our T is equal to 2 pi square root of L over G. Now quickly check how they relate. The period is proportional to the length. So to increase period, we should increase the length. So the answer there should be option C, increase the length of the string. Number 8, a car traveling at uniform speed, okay, of 120 km per hour passes 2 stations in 4 minutes. Calculate the distance between the 2 stations. Quickly, given speed was given as 120 km per hour and the time was 4 minutes. Now quickly, we need to convert these values, okay, although the distance was in kilometers. Let's convert the time to hour. Remember, 60 minutes make an hour, so 4 minutes will make x. So do your mathematics. X should become, so it's 4 over 60 as our x. Let's solve. Remember, so our time rather is 4 over 60. So v equals to x over t. That means x should be v times t. So our distance should be 120 times 4 over 60. This should work. Okay, 0 cancels 0. 6 here 1, 6 here 2, and the answer should be 8. So the answer should be 8 kilometers. Number 9 says a machine has an efficiency of 60%. If the machine is required to overcome a load of 30 Newton with a force of 20 Newton, calculate the mechanical advantage. Quickly recall, like we said earlier on, MA is load over effort. So the load in the question was given as 30 Newton and then the effort was 20. So this should be 1.5. Number 10, a body weighing 10 Newton in air is partially immersed in water. It displaces water of mass 0.3 kg. What is the upthrust on the body? Now recall, okay, upthrust basically is rho Vg, density of liquid, volume of object, and then G. And remember, rho L times VO actually can refer to the displaced mass of the vibe. So I can just say upthrust is the displaced mass times gravity, and we're given that value as 0.3 and times 10, so the answer should be 3 Newton. Number 11 says a mercury in glass thermometer reads minus 20 degree at the ice point and 100 at the steam point. Calculate the Celsius temperature corresponding to 70 degree on the thermometer. Now recall, we're going to draw our temperature scale. So this is for Celsius, 100 and 0 as steam and ice point. And for the guide we're giving, the steam point was still at 100, but the ice was at minus 20. And we're asked to find the value on the Celsius when it reads 70. Quickly, we're going to interpolate, okay? So I'll actually use the middle minus down over up minus down. Let's go from here. We'll have 70 minus 20 over 100 minus 20 equals C over 100. We have over here 70 plus 20 over 100 plus 20 equals C over 100. This should be 90 over 120 equals C over 100. Let's divide. So 0, take out the 0 here. Okay. So we have 90 divided by, so C should be 90 times 10 divided by 12. Let's divide if you can divide. 2 into 12 is 6, 2 into 5, 2 into 10 is 5. Okay, 3 into 6 is 2, and 3 here is 30. 2 here is 1, 2 here is 15, times 5, that should be around 75 degrees Celsius. Number 12 says a brass rod is 2 meters long at a certain temperature. Calculate the linear expansion of the rod for a temperature change of 100 Kelvin. Take the linear expansivity of brass as 1.8. Let's solve that quickly. So we're giving alpha as 1.8 times 10 raised to the minus 5 per Kelvin, and we're giving the original length as 2 meters and the temperature change as 100 Kelvin. Now recall that linear expansivity is the change in length, as the expansion over the original length times change in temperature. So we are asked to find this value, the expansion. Okay, so change in length should be alpha L naught times change in temperature. Let's multiply that together. So 1.8 times 10 to the power of minus 5 times 2 times 100. So let's see what that will give us, the calculator. 1.8 times 10 to the power of minus 5 times 2 times 100, and that should give us 3.6 times 10 raised to the minus 3. And let's see, okay, let's put that in decimal. Sorry, that should be 0.0036123. Yeah, option A, 0.0036 meters. Number 13, a body of specific capacity 450 joules per kilogram per Kelvin falls to the ground from rest through a vertical height of 20 meters. Assuming conservation of energy, calculate the change in temperature of the body striking the ground level. Now recall, we are conserving energy in this question. We are moving from potential energy to heat. Okay, potential energy basically talks about mgh, and heat is mc, change in temperature. So the m's can take out each other. Okay, and we are asked to find, let's see, the change, the was find change in temperature. From the board, we can say that change in temperature is GH over C. G is 10, the height was given in the question as 20 meters, and the C for the body was 450. So let's divide the values we have on the board. So 200 divided by 450, and that should be 4 over 9. So the answer is 4 over 9 degrees Celsius as the answer. Number 14, hot water at temperature of T is added to twice the amount of water at temperature of 30 degrees Celsius. Okay, if the resulting temperature of the mixture is 50 degrees Celsius, calculate T. Now we are conserving. Okay, so hot water and cold water. So the quantity of heat given off by hot equals the one received by the cold. So for quantity for hot, we have M for hot, C for hot, and temperature for hot. We also have M for cold, C for cold, and temperature of cold. Now recall, if you are with my students in real life, I always tell my students that the C for hot water and the C for cold water are always the same thing, because water na water. So CH can cancel CC. Okay, so we don't have MH for hot and temperature for hot equals MC for cold and temperature for cold. Let's see the parameters in the question. Now we are told that the cold water, okay, was twice the amount of hot water. Okay, so I'm going to say MC is 2 times MH. Okay, so from that we're going to solve the question now quickly. So MH remains MH. The temperature change for the hot will be the temperature of the hot minus the temperature of the mixture. MC is 2 MH, And then the one for cold is temperature of the mixture minus temperature of the cold, which was 30 degrees in the question. So solving that, we're going to have mH takes out mH, T minus 50 equals 2 times 20. So T minus 50 equals 40, and we can say T should be 40 plus 50, and the answer should be 90 degrees Celsius. Number 15, an air bubble of volume 2 cm cube is formed 20 meters underwater. What will be its volume when it rises to just below the surface of water if the atmospheric pressure is equivalent to a height of 10 meters of water? Now quickly, we are dealing with pressure and volume. So we're going to be applying Boyle's law that says P1 V1 equals P2 V2. Now originally the bubble was below the water surface at 20 meters. So the pressure at that point is going to be the height. So P1 is going to be the height of the water plus the atmospheric pressure, and that should be 30. Okay, 30, it was in meters, right? Yeah, 30 meters. So let's come back to cm, and this should be 30 times 100, and that should be 3000. So this was the value for the pressure 1, and pressure 2 is just the one for the water, which was 10, and that's 1000. Okay, so quickly let's solve this question with Boyle's law. So P1 is 3000 times the volume. The volume was 2 cm cube equals P2 is 1000, and I think we are asked to find the volume at the second part. Okay, so quickly let's divide. 1000 takes out this values, 2 times 3, so the answer should be 6 centimeter cube as the volume. Number 16, the pressure of a given mass of gas changes from 200 per meter squared to 100 per meter squared, while its temperature drops from 127 to minus 73 degrees Celsius. Calculate the ratio of final volume of the gas to initial volume. Now quickly, we have pressure, temperature, and volume. So basically, we should be relating with the general gas equation. P1 V1 over T1 equals P2 V2 over T2. So let's put our values quickly from what was given to us. The pressure P1 was 200, okay, in the question we don't know V1, but the temperature one was 127, so we have 127 plus 273, and P2 was 100, we don't know V2, but the temperature 2 was minus 73, so plus 273. Before we solve that, 100 takes out this value, so now our calculator, let's see, hold on. Okay, so 127 plus 273 gives us 400. So we have V1 over 400 equals V2 over, this should be 200, right? So this takes out this. We ask find the ratio of the final to the initial. We need V2 over V1. So this should be this 1 and this 2. So V2 over V1 should be 1 over 2. That's the answer, 1 ratio 2, option D. Okay, question number 17. The temperature of a glass vessel containing 100 cm cube of mercury is raised from 10 to 100 degrees Celsius. Calculate the apparent cubic expansion of mercury. Now quickly, from the what you can see on the screen, we have to find the apparent cubic expansion. So we need the expansion for the glass and the one for the mercury as well. Now from our previous formulas, you can agree with me that the change in volume can just be the cubic value times the original volume times change in temperature. So this glass will have glass here, and we'll have mercury as well over here. So we're going to be doing the same thing for both of them, just different parameters. Now quickly, the one for the glass was given as, let's see, the glass, yeah, 2.4. So we have 2.4 times 10 raised to power minus 5 times the original volume was 100, and then the temperature change from 10 to 90, that's 90. And over here we're going to have same like 1 for mercury, 1.8 times 10 raised to power minus 4, yeah, then times 100 times 90. So let's see the one for the glass first. I'm going to multiply that to our calculator quickly. Okay, for the glass we have 2.4 times 10 to the power of minus 5 times 100 times, then times 90. We have 0.216 for the glass, so 0.216, and then for the one for the mercury, let's see, we're going to have for that case 1.8 times 10 to the power of minus 4 times 100 times 90, 1.62, we have 1.62. Now quickly, the apparent expansion is going to be the one for the mercury minus the one for the glass. So 1.62 minus 0.216 minus 0.216, and the answer should be 1.404 as the answer. Okay, number 19 says, how much heat is required to convert 20 grams of ice at 0 degrees Celsius to water at the same temperature? Now, since we are not changing temperature, it means we are changing state. So we are applying the latent heat formula. So we call Q equals to ml, okay? So we're going to say Q, the mass was given as 20 grams, convert to kilograms, we have 20 over 1000 times. The latent was given as 336. Oh, it was also in grams. Let's just work with our grams, okay? So we have Q to be 20 times 336. What should that be? 6720 joules per grams. Option B. Okay, number 20 says, when two objects P and Q are supplied with the same quantity of heat, the temperature change in P is twice that in Q. If the mass of P and Q are the same, calculate the ratio of the specific capacity of Q to P. So we have quantity for P and quantity for Q. Now we're told that the quantity of it were the same, so they're equal, okay? And then we're going to solve this from here. The temperature change in P, let's do that. The temperature change in P is 2 times the value for the one for Q. Recall, we can say MP CP change in P equals MQ CQ change in Q. Now we're told that the masses were the same. So MP takes out MQ. So CP change in P is twice change in Q equals CQ and change in Q. Change in Q takes out change in Q. We have to find CQ over CP. So we need this. So CQ over CP becomes 2 over 1. The answer should be option B, 2:1 as the answer.